Hello everyone, this is Aditi Mishra, and the analytical instrument that I have chosen for this assignment is a Zetasizer. A Zetasizer is an analytical instrument primarily used to measure three main parameters, which are the particle size. It is measured through dynamic light scattering technique, also known as the DLS technique. Secondly, it measures zeta potential. It is measured through electrophoretic light scattering or the ELS technique. And lastly, it measures molecular weight, which is measured by SLS technique or static light scattering technique. In this video, we will go through detailed analysis of how Zetasizer measures the particle size only. Now, how the dynamic light scattering technique works. The first step is that the DLS measures the Brownian motion of particles in suspension and relates it to their size. Brownian motion is the random motion of particles. Generally, small particles tend to diffuse quickly as compared to particles of larger size. The rate of Brownian motion quantifies as the translational diffusion coefficient, which is often represented by capital D. When particles are illuminated with laser, they deflect light. Due to dispersion, the intensity of light fluctuates with time, which is measured by the detector. The smaller the particle, more quickly it diffuses, which translates to more rapid fluctuation and vice versa. Now, rapid snapshots of light scattering signals are taken rapidly, one after another, always comparing these back to original signal between consecutive snapshots which are on the scale of nano or microsecond, and the intensity of the signals are very similar. But when we look at the snapshots at longer interval, the similarity begins to decrease. Eventually, the intensity of the signal changes completely. This process is called autocorrelation. Now, the correlation function which we have created enables us to extract the translational diffusion coefficient. These values are used in the Stokes-Einstein equation to obtain our size information. The variable such as solvent viscosity and temperature needs to be known. The following is the video of the DLS technique which would help us imagine what the process looks like. So, a beam of laser hits the molecules in random motion, which then emits light. The detector then measures the absorbance of the light, translating the signal to the correlator. Zetasizer has several applications in the industry. Some of them are: number one, characterizing nanoparticles, colloids, and emulsion. DLS is widely used to measure the size and distribution of nanoparticles. Ensuring the proper size of nanoparticle is crucial for their intended applications, such as drug delivery systems, where particle size impacts bioavailability and the cellular uptake of the molecule. The second application is assessing protein aggregation and stability in pharmaceuticals. Aggregation can affect the stability and efficacy of protein-based drugs, potentially leading to reduced activity or immunogenic reaction in patients. By detecting even small aggregates, DLS ensures formulational stability and helps in developing safer biopharmaceutical products. The third application is the Zetasizer helps in studying polymer size and molecular interaction in solution. It helps in characterizing colloids and polymer solution, which is crucial for understanding the behavior in processes such as coating, drug delivery, or hydrogel transformation. The third application is the Zetasizer helps in studying polymer size and molecular interaction in solution. It helps in characterizing colloids and polymer solution, which is crucial for understanding the behavior in processes such as coating, drug delivery, or hydrogel transformation. This is what a Zetasizer looks like in real life. The components of Zetasizer are laser, sample cell, detector, temperature control system, and a correlator. A Zetasizer can measure the size of particles ranging from zero point 0.3 nanometer up to 10 micrometers. The laser has a wavelength of 633 nanometer, which is in the red region of the visible spectrum. Some models may also use different laser wavelengths, such as 532 nanometer, for specialized measurements. People always confuse between zeta potential analyzer and a Zetasizer, but both of the equipments are different and serve their own purposes. A zeta potential analyzer functions on only ELS, while a Zetasizer combines dynamic light scattering, electrophoretic light scattering, and static light scattering techniques. Application scope of Zetasizer is broad as compared to that of a zeta potential analyzer, which is not as broad comparatively. A Zetasizer can analyze nanoparticle, protein, polymer, colloids, and complex formulation, whereas a zeta potential analyzer measures the stability and surface charge of colloids and suspension. Zeta potential calculations are derived from electrophoretic mobility of particles in an electric field. The following image is of a zeta potential analyzer, and the one in the right side is of a Zetasizer. In India, there are several manufacturers of Zetasizer. Some of them are mentioned below, which are Malvern Panalytical, Brookhaven Instruments, Anton Power, Better Size Instruments, Microtrack MRB, Particle Metrics, and Colloidal Dynamics. They offer Zetasizers of different types and different models. There are several advantages of the equipment Zetasizer. Some of them are that the equipment is non-invasive. It requires minimum sample preparation, preserving the sample integrity. It provides quick measurements, often within minutes. It requires only small volumes of sample, which is ideal for precious or limited samples. A Zetasizer has high reproducibility. It has advanced softwares and algorithms that ensure consistent and repeatable results across multiple measurements. Allows precise control of sample temperature during measurements, which is useful for studying temperature sensitive materials or reactions. A Zetasizer is compatible with various solvents. It works with water and a range of organic solvents, enabling analysis of diverse chemical systems. However, there are limitations of a Zetasizer too, some of them being the Zetasizer is sensitive to dust and impurities. It has high initial costs and maintenance expenses which may not be feasible for all laboratories. It provides mean particle size. The mean size is typically reported as the Z average diameter, which is the intensity weighted harmonic mean diameter obtained from the DLS data. It is less accurate with polydispersed sample. The Zetasizer struggles with highly polydispersed samples where particles vary widely in the size. The equipment has limited particle size range. It works with particle ranging from only zero point 0.3 nanometer up to 10 micrometer. It is ineffective for very large particles which may sediment or for extremely small particles beyond its detection limit. Limited to solvent compatibility with the instrument's optical and material components. Aggressive or highly viscous solvents may not be suitable. Assumption of spherical shape. Particle size analysis assumes particles are spherical, which may lead to inaccuracies for irregular shaped particles. So thank you everyone. This was all about Zetasizer, its working principle, its application and various other details. This was all what I know best of my knowledge. If there are any inaccuracies in the following video, please let me know in the comments. Also, if anybody has any questions, they can drop in the comments. I would reply to them. Thank you.